Okay, we are live. Thanks for tuning into the Sheet Metal Shaping Podcast, where we discuss the pursuit of sheet metal shaping education through traditional coach building techniques. My guest today on the show is Brian Hainer from Connecticut, and we are talking about scratch building a Yoder power hammer. What's up, man? How are you?
I'm doing real good, man. I appreciate you doing shows like this. This will really get the information out there to people.
Absolutely. So I think how did we meet? I think I came across you on a YouTube video. Was that what it was?
I believe that's where most people find me on YouTube, and
I think that's what
you
it was.
probably saw me talking about building a hammer.
Yeah. And then somehow I tracked down your email. I said, "Hey, come on the show. Let's talk about this
Yeah,
thing."
I'm not one of the easiest people to find. It's just kind of overwhelming with the work that comes in, but here I am, and we can discuss that hammer. It was a rather large build, but we can go over it piece by piece if you like.
I love it. Tell the folks before we get into the hammer itself. Tell the folks a little bit about yourself.
Well, there's a couple things I've always done. I think most guys that are fooling around with metal have been since they were just little kids. They've been curious and taking things apart and trying to put them back together and figure out how things work. I started out building houses and doing some carpentry. And on the side, I was working on cars and doing sheet metal work and body work. Um, and then I got into furniture building, and that's what really helped me start to see shapes. And as soon
Mm.
as that clicks in your mind, seeing shapes and how to get to them, it just opens up a different world of metal shaping. So that actually happened for me uh, building furniture,
Wow.
and that enhanced my metalworking. And I think I was probably about 22 or 23 when I got into a commercial space. I got my first commercial building, and I was finally able to get away from neighbors uh, who didn't want a hammer, who didn't want to live next to a guy with a hammer. So
That's right.
I built my hammer when I got to my first commercial shop, and that was oh god, early 90s.
Yeah.
So I hate to date myself like that, but I built that hammer in 93, 94, something like that.
Oh,
It took a while to
wow.
build, but I've been hammer on that ever since, and not a single breakdown in all those years.
That would have been a very different time too. Pre-internet, pre-YouTube, pre-everything. You're down to magazines and how-to manuals, right?
I was looking for a hammer forever through the big places, Hemmings, anywhere that people were into cars and doing stuff like that. Back then, if you found a hammer, guys wanted $50,000, $100,000. They thought they had something. I kind of missed the boat on getting the reasonably priced hammers, um, and I just got so fed up uh, that there was a Yoder not too far from me that I patterned off of,
Mm-hmm.
and took off from there.
That guy wouldn't sell it.
Oh God, no, no. When people have them, they're not a chance to sell them, especially now. I mean, nothing like that now. And even back then, the few guys that I was able to contact and measure their hammers and do stuff like that, um, very still like the old guys, very secretive, very protective of their hammers. They didn't want, you had to really work just to get your toe in the door.
Yeah.
And God forbid you had a piece of cardboard and a Sharpie with it, and you wanted to take a pattern off their arms or
Whoa.
something. Oh my
Yeah.
God, no, who are you? What are you doing? So it took a while to get some people comfortable with me, but I did get real nice patterns, and my hammer is built as a weldment. Obviously, I couldn't cast anything like that,
Mm-hmm.
and I just went crazy on it. And it's a large hammer, and I had used a lot of um, the smaller Yoder, the larger Yoder. There was some companies coming out with, I don't know, like tube welded hammers, and I was super disappointed with those.
Mm-hmm.
So I decided to build, and my hammer, as it sits right now, is just about 13,000 pounds.
Cool.
So it's what you call a monster, but it is
Holy.
silky, silky smooth.
Why do you think, like, what there's a culture around this power hammer stuff? There's a culture. There's an air around it. Um, it's just, there's something about the power hammer that, I don't know, brings out the best in people, brings out the worst in others. People are secretive. People are willing to share. Like, why? It's a tool. It just goes like this. Why is it that the power hammer has such a seance around this type of equipment?
I
What is
have
it?
been trying to figure that out since the day I wanted to build one.
Hmm.
And I'm pretty easygoing and pretty free with information. And when I ran into a brick wall trying to get information on the hammer, I realized the guys were, I don't know, crazy. You know, like you say, it brings out the best and the worst in people.
Yeah.
People will come in the shop and they'll see a beautiful part that I'm making come off the hammer, and then they'll say, "Hey, do you know how to use that thing?" And you know, it's kind of crazy. I don't understand it. Um, there's a few guys in that have hammers and have classes and this and that, and they're not promoting stuff like what you're doing. They don't let the information out, basically.
Hmm.
You know, it's completely the opposite of what you're doing.
Sure.
So I really appreciate what you're doing with getting the information out there.
Yeah. Well, let's talk about the build itself. So when you got started, you had mentioned patterning and Sharpies and cardboard. So when you first got started, how did you come up with this idea? Where did you start when you wanted to build it?
I realized I wasn't going to find one, and I realized I wanted a hammer much heavier than what I tried. I tried a few hammers. I didn't like them. I wanted to make it heavier. I started with the column first. So I've got two 8-foot by 5-foot sheets of 3/4 plate, and I bent them in a U shape to make two U's that I welded down the center to make a big column.
Mm-hmm.
And that started another thing. I mean, where am I going to find a press brake that big?
Yeah.
So
oh God,
it took a 400-ton press brake to do that.
That's like offshore manufacturing type of stuff. That's heavy duty, man.
It was hard to find somebody. The guy was kind of sympathetic with my cause, and he did it for me.
Wow.
And I spent I don't know, a week welding that column together, cutting out little peak holes in there, putting the inner bracing in it. It's what is it about? It's about 30 by 30.
Yep.
And
that's a big column, Brian. Holy.
The column is where I started. It has a lot of cross bracing in there. It has a lot of double 3/4 plate where the arms bolt up. And I welded inside and out. So I was in that tube welding with fans blowing, running some big jet rods, some 70-24 on the inside, and it was it was a process, I'll tell you that.
Wow.
So with the column built, it was easy. The column, I think, was the most welding and tricky part.
That's a big column. 30 by 30. Holy smokes.
Yeah, that sits on a 5 by 5 2-inch thick solid plate.
Really? Wow.
And after the hammer was built and I started using it, that would dance right across the floor.
Really?
You'd have some harmonics going on, and it was sitting on that big plate, and that hammer just walked right across the floor. I had to actually pin it to the floor.
Did you fill it with sand when you were done?
I didn't. It's so solid. It doesn't need anything.
Yeah. I mean,
I did have to brace the arms with the wood, with the triangular shaped pieces of wood there to support the arm. That makes a huge difference.
Mm-hmm.
And the arms, I had the arms flame cut out of 2-inch thick steel, and then I went around that with like some 1/2 inch by 4 just to make it look like a casting as best I could, you know.
Yeah.
The arms are 2 inches thick. The upper cradle, that's another 3/4 inch thick bent piece. So it just started adding up. I mean, the weight was just crazy. And once I got the whole entire weldment built, that's when I started in on the motor and the slide. I did not use a dovetail slide. And my whole slide mechanism is completely different than people are rolling over in their graves now because I use the linear bearings instead of a
Oh,
dovetail.
you're not a purist. Oh my
Oh
God.
my God, it's crazy.
Yeah. So the arms.
Uh,
Let's talk about the arms. So we got through the base and the mast. Obviously, super heavy duty. What do you have in your shop to move that thing around?
Nothing. That
Oh,
I moved almost all my equipment from the shoreline of Connecticut to where I am now. I bought a farm and I moved everything there.
yeah.
And I pick things up with a jack and I put pipes under them. Well, not on the hammer. I put solid bar under that, and then I just kind of roll it in place.
Nice.
Just on bars.
Hmm. And then in
Um,
terms of like logistics, were you doing this by yourself? Did you have people? Did you have help? I mean, this sounds like a pretty big operation to do as a one man show.
yeah, one man shop.
Yeah.
One man shop. Everything happens slowly, but I get it done.
Yeah.
Um, that was a big piece. I have an iron worker, a big iron worker that's 35,000 pounds. The same thing. That one I used the tractor to actually move around once it was on the bars.
Wow.
But everything is in place. Nothing's moving again. They're gonna have to, when I'm gone, somebody's gonna hit the jackpot and get everything for a penny. I guess I don't know.
That's right.
But yeah, there's a lot of tonnage in my shop right now.
So you talked about the arms. What were they? 2-inch thick plate, flame cut?
2 inch thick,
Yep.
and and like I said, I took some 4 inch wide by half-inch thick and made and ran that all around the shape of the arm and welded all that. And I put the lower arms on first, so I had something to stand on to put the upper stuff on. But I put the lower arms on first, and I made massive die blocks, and I have probably, I don't know, 6 or 8 inches of aluminum plate, 1/8 inch plate under that.
Wow.
Some guys use wood and canvas under their die block. I found I like the aluminum
Mhm.
because you could take it out and you could adjust if you want a bigger die or a smaller die, or you got to get a real deep shape. You could take out the aluminum easily. So that works for me. And
What do you think's got the best vibration absorption properties for that lower die holder?
the aluminum under the die block, and then I have 4x4 hardwood blocks going directly from the bottom of my arm to my 2 inch base plate.
Mhm.
And before I put those in, you could watch the arm move when you hit it. And I've
Wow.
got some 1.25 inch tie bars back to the main. You could just watch that arm resonate.
Yeah.
I didn't think it would happen. I was like, I don't need those wooden blocks under there. It took 5 minutes for me to say, well, let me go get some hardwood and make some that was the single most, that was the biggest change in making it more solid.
Wood. Who'd have thought?
Without those, it's completely different hammer without that wood in there.
Really? And that just sits kind of like on a 45-degree angle or a 22 or something back into the
That
machine.
goes right back down. Oh, it's a sharp angle down from the arm all the way back to the base. Is
Mhm.
probably a 45-degree angle, and the two arms, there's a piece of rod through them, so you could tighten them up and squeeze them together, and that'll push the arm up.
Really? Wow. Who would have thought that a piece of wood would make such a difference, right? Over all these years and all the hammering that people have done. That's
Night
that's
and
the
day
trick.
difference. It's absolutely amazing, the feel of the hammer.
Really.
And I run bigger dies than most people anyway. And on my shrinking side, I'm hitting real hard. And without those blocks, it was just, I mean, it's amazing. The difference is night and day.
So when you get resonation, resonation, is that a word? When the lower arm gets
sounds good to me.
Resonating, when the lower arm gets resonating,
Yeah.
what's really happening at the molecular level or from a visual perspective? Like what's happening there when that's shaking around?
It's almost like if you had a steel carpenter's hammer and you hit a heavy plate, a table with a 1 inch top thick plate, and it just wow, yeah, the noise and the resonation you'd hear would be crazy. And then you hit it with a dead blow,
Mm-hmm.
and you feel the difference between a hammer and a dead blow. And that is exactly what it feels like between having the wood and not having the wood.
Really, really. So
So
it's ringing.
if you hit a table hard and that hammer came right back in your head like that, you'd be like, whoa, what the hell's going on there? And then you hit it with a dead blow. That's exactly how it feels.
Really. So it's
It
this
was,
ring. It's this outward ring.
yep. And it wouldn't, it would set a on the shrinking side of my hammer. It would set a tuck okay,
Mm-hmm.
but the die would act completely different. Like it would bounce back faster than it should. You know what I mean? Like
Yeah.
the spring is kind of slinging that thing down. You could start off at slow speed and the dies aren't even hitting. And then the spring starts compressing and the die starts making contact. Well, with the wood, it's just normal. It makes contact, it goes back up, makes contact, and goes back up. When it hits without that wood, it shoots up.
Yeah.
And it just, everything goes wrong. I mean,
Sure.
everything was going wrong. So
Sure. And it's amazing that's still happening with, with such a thick arm too, right? Like you got cross blocking and you got rods and you got all the stuff happening there, but still rings.
never in my life did I expect that. I didn't have the wood to begin with. And I saw it on a hammer that I took the patterns off of. I saw the wood was there and I'm like, man, my hammer is so big. I don't need that. Well, like I say, 5 minutes later, I was cutting the wood out.
So do you think you could have gone less on the materials when you were carving those arms out? Like if you went with 1-inch plate or you went with box tubing that you put, 4-inch plate across the tops on, or different materials, do you think that would have made a difference and you could have just gone with the wood and you'd be okay? Or do you still think that knowing what you know now, you needed that thick material?
I would not build a hammer lighter than this.
No.
I wouldn't try and do one lighter than this.
Mhm.
I have tried probably every hammer out there, new ones, old ones, and other guys that have used hammers and then tried mine. They're like, this is silky smooth. I can't believe it.
Wow.
And I agree. The new ones, there's nothing wrong with the new ones. They shape metal, but differently.
Mhm.
Differently. Now I make all my own dies as well. So my upper dies are heavier than most.
Right.
I have one side of the hammer that is, I mean, the shrink dies could practically be welded in there because I don't ever take them out.
Mm-hmm.
But I have my normal set of shrink dies, and then because I can work 14 gauge on that hammer without a problem.
Sure.
But I have a bigger set of dies with more clearance for heavier material. So when I'm shrinking and I use the big shrinking dies and a longer stroke, it hits hard, but it doesn't mangle the metal. I make my dies in such a way where you could practically go from the shrinking side of my hammer to your planishing hammer with no, not moving to planishing dies on the hammer. I don't like a messy shrinking die.
So what's the difference between the die that you're building versus what some of the other available dies on the market might be?
Whew, that's a good question. I don't know why the dies on the market leave so much. I'm going to call it manglement of the metal. I see dies that just tear it up, and I'm like, wow, what are you doing?
Yeah.
And I'm lucky because I have all the equipment to make my own dies, but I don't think the people making the dies are the people using the dies, and I believe that's the problem.
Ah.
I believe you have to have time on a hammer to appreciate a good die. And I've seen a lot of guys that can't set dies up too well, and they got things off, and I'm like, dies are another thing that brings out the worst in people because there's true radius lovers of a die, and like myself, all my dies have a flat spot on them.
Right.
And basically, I could end the world by saying I got the flat spots on my dies, talking to people like, hey, the world's going to end if you got a flat spot on your die. Well, that's just how it is. And you have to feel your way through on a hammer. You'll make adjustments. You'll try it
Mhm.
for a while, and you'll say, well, I'm going to make an adjustment, and it's just seat of the pants. You just have to feel your way through.
For sure. Are you heat treating your dies? And then we'll go back to the fab of the arms, but are you heat treating your
Yeah,
dies?
I make all my dies out of S7, and they get heat treated to like
Yeah.
a Rockwell a 57 or around there, and they last forever. I mean, you can beat those things forever, and I've never had one fail.
You know what? Actually, on the topic of dies, since we're here, explain to the folks who are listening what the difference is between a heat treated and a non-heat treated die, and what the process is of actually manufacturing that component.
I use both. I use my shrinking dies and my planishing dies are all heat treated. They're all made out of S7, and
Mhm.
they're all properly heat treated.
After machining.
Well, yeah. When I do have um, like a polyurethane upper die, when I sink a piece of polyurethane into an upper die and I have a rounded or a specific shape on the bottom, I don't harden those dies because they're not metal to metal contact.
Mhm.
And they're made out of a different material. Um, a hammer is not like a wheel where you can have hardened and unhardened dies. Everything should be hardened unless you're using a rubber or polyurethane upper die.
And then when you're making these things, you're machining them in-house and then sending them out for heat treat?
Yes, it's
Yeah.
I don't have the capability to get that S7 up to 1700 degrees
Yeah.
and come down real easy. So I have a local company does all my hardening, and then I polish them after I get them back.
Yeah. How soft is S7 when it comes to you?
You can machine it. It's like very nice. It machines almost exactly like 4140.
Hmm.
It's not hard at all. It's easy on the tools.
Mhm.
It's not bad. Um, and then once it's hardened, I mean it's crazy hard. I mean
Yeah.
you can, like I say, I've been hitting steel for God since '93, and my dies don't have a bit of wear on them.
Yeah. Any risk if you didn't harden it of wearing a flat spot in that die? And if so, how long would that take?
That would happen immediately.
Oh, yeah.
You'd notice that the first time you used it,
Mm.
and just the you'd have to have a face shield on because I'd be afraid that the die would come apart.
Oh, really?
I wouldn't. Yeah, I would never try an unhardened die on the hammer at all.
Yeah. When you're doing this, how much does it cost to get a set of dies heat treated? Let's just say you do, I don't know, 5 uppers, 5 lowers, so 10 dies in total. You machine them up, you send them out. What does that cost?
They go by weight. The company I use goes by weight. So if you sent something in that weighed 1 pound, your
Mhm.
minimum is 70 pounds. So you pay for 70 pounds.
Gotcha.
So I do stuff in big batches, and I'll do a dozen dies might cost about $600, say.
Mhm.
Um, whatever it is, it's worth it because I know it's right.
Yeah.
I get my specs on exactly where we're at, and I know what it is, and I can trust their hardening technique. I don't mess around with the hardening at all.
Yeah. If you use mild steel in place of an S7, what would happen?
You would smear the metal. It would actually transfer into the sheet metal. It would I don't know, it might last for one part, and then you'd have to reshape it and tune it up, and then it wouldn't last. It wouldn't last.
Yeah. Yeah. And then in terms of the actual machining process itself, on a mill, on a lathe, are they square, are they round? What do you prefer?
I prefer to do everything on the mill. I have some very crazy shaped dies that I use with the rubber upper that are round, and that's done on a lathe. But 99% of my dies are made on the mill, and I kept a 5-degree angle as original with a 1-degree wedge,
Mhm.
and that locks them in there tight. I mean, you just knock that wedge in there, and it's not moving.
You're talking about the
So
dovetail on the bottom?
the dovetail on the bottom, yeah.
Yeah.
So it's a 5-degree. I had a 5-degree cutter made, and that just works. I mean, that worked from the beginning of time, and it still works now. And I see guys trying to put things in with set screws, and that doesn't work.
Right.
Some of the newer machines, the more expensive machines, have a pretty nice the way of locking things in and taking dies out. It's very fast and it seems to work okay. But the newer machines, um, they don't have the same feel. I
Yeah.
mean, maybe they work pretty quick. Um, but on my hammer, when you're jamming on my hammer, you can move some metal and you can move it fast.
In
So
terms of getting the actual radius on top of your die, how do you nail that radius? You say, I want this radius on this die. How do you get that?
that's all done by hand. I have an extremely long uh, belt sander. It's an old, I don't even know who made the machine, but it's probably got a 20-foot long belt on it, and um, it's 4-inch wide sanding belt.
Yeah.
And I put a welding glove on and hold it under the belt, and I hold the die on the top of that, and I actually just shape it with my hand.
Wow.
I take the sanding belt, what I say, with a big welding glove on, and I kind of put that on the die as I want it, and you just keep checking it. It's just 100% handmade.
Yeah.
It's
It's a feel thing.
I don't have any CNC stuff, and the CNC stuff, um, they can get your radiuses and they can get everything right, but you still gotta polish it heavily. Um, and then let's say I have a die that's a 24-inch radius. Once it's a 24-inch radius everywhere, I'll check it with a gauge. I'll go in there and I'll put a flat on that. About a 24-inch die might have a flat about the size of a quarter.
Right.
And if you try true radius dies and you mark up, you're doing a door skin or something, and you mark it up all the hell with a true radius die, and you're like, oh man, what the hell did I do? And then you do it with a flat die, and you're actually moving the metal, and there's no marks in it. You'll see the difference. It's something you have to visualize it and see it as it's happening, because you can watch that metal get a million little marks in it that you got to get out somehow, compared to if you have a flat top die.
It's so funny because, like, as you say before, we could part the seas with who likes the flats, who likes the true radius. I
Yeah.
watched the thing the other day and the guy was like, how do I make something round with something flat? And I was like, oh, that's a good point. And then, we're having a conversation now and you're like, you're going to leave all these marks in the panel with something round. You got to use something flat. It's so funny, right? It's just like whatever works for that person. It seems like
Exactly.
go with what works for you, right?
100%. And the thing is, you have to watch the guys that have never done anything compared to the guys that this is how they make a living.
Yeah.
It's just, I've put it to bed in my mind what works and what doesn't work, and how fast I can get a panel out and how fast I can finish a project.
Yeah. Yeah. So going back to your arms, we talked about how they were constructed, flame cut, all the banding and stuff that you put on them. In terms of the design itself, did you replicate the Yoder and their specs specifically, or did you just kind of take some inspiration from that?
The lower arm is directly off of Yoder, the large Yoder, because I like that arm the best. There's Yoder made a few different arms, and I picked the one I like the best. I made a cardboard template of it and cut it out. The upper arm is a little bit different because I'm using a variable frequency drive. I'm not using a clutch setup in mine.
Yep.
So I had to make room for the motor. And inside I have a fan blowing on the motor all the time when that's running. And then I have a big, you'd call it like a flywheel. It's not really big in diameter, but it's a heavy piece of steel. It's probably 8 inches in diameter and about maybe 6 inches thick. And it just connects my shaft to the motor, and it gives it momentum.
Right. Right. So as that hammer comes down and around, it's got lots of force to go back up.
It does. Yeah. I've got that right at the back end of the shaft there.
And what type of a horsepower rating are we talking for your motor?
5 horse. I got, it's a double, so I got 2 5-horse motors.
Gotcha. 3-phase?
Yep.
Yep. That'd be a big VFD, no?
It is.
Yeah.
It is. And it's I actually had a clutch setup on this when I first started, and it, it wasn't bad. It was I was using it, but I like the variable frequency drive much better.
Is there more
It's
control, in your opinion, than
yeah, 100%. Yeah,
belt setup? Yeah.
100%. Um, I mean, you could stick a bottle on there and put a cork in with it. You know what I mean? It's very very user friendly.
Yeah, I mean the advances in modern technology from a coning or a cone clutch setup or a belt drive or like whatever's on these alternative machines, like a VFD is it's a no brainer.
Oh, it's fantastic.
Yeah,
It's fantastic. I love it. Love it. And it hasn't given me a bit of problem in all these years. And I'm still like I have a blacksmith hammer. I have a little giant 100-pound blacksmith hammer, and
yep.
that has the original clutch on it. And you use that big old clunky thing, and you're tickling that foot pedal, and you're like, yeah, it's gonna catch, it's gonna catch. I just wanna hit this metal softly, and you appreciate it from the cone clutch of a blacksmith hammer to a
Yeah,
variable frequency drive on a sheet metal hammer, and it's fantastic.
yeah. When did you make that switch?
Oh, it was probably 6 months after I had a complete clutch setup built, and I was using it on each side of the hammer, and it
Mhm.
pained me to take all that stuff out of there. I had it all plumbed in nice and stuff. It hurt to take it out, but that's how important it was for me to get a better feel of the hammer.
Anything you do differently now that you know what you know, from the fabrication side, from the time spent, from the overall design, vibration, like going back, what would you do differently from the get go if you were to recreate this?
I put so much time and thought and care into the hammer, and it came out actually much better than I thought it was gonna come out.
Mhm.
And I wouldn't change a thing. I mean, there's nothing on there. I mean, I wouldn't go through the trouble of making a cone clutch and then taking it off. But yeah, I would just absolutely stick with the VFD and be happy with it.
Yeah.
That was a little bit of a mistake, but you learn. And that was the only thing. The only bad thing I think that happened on that hammer was the cone clutch.
Total time spent, total dollars spent.
Oh man, steel was a lot cheaper back then. I
Yeah, man. Holy.
It probably took me back when I started that. I wasn't doing the machining, so the shaft and some of the mechanism, I had a friend of mine doing that, and he was dragging on that.
Yeah.
So I probably have, between working, and this was just on the side I was doing this, so
Right.
I probably have about 8 months of build time into it. Oh, and I'm gonna say,
And 8 months, like evenings and weekends type of thing, right?
yeah.
Okay.
Um, I probably have about $7,000 into the whole thing. That's buying all the steel, the linear slides, you know, yeah, probably about 7,000, and those are $93. So
Yeah.
just the steel now will scare you. I mean, if
Right.
I said, hey, I want to build something that weighs 13,000 pounds, and you're paying a couple dollars a pound for steel now. It's just, I mean, back then I was getting the steel for, it seems like nothing in today's dollar.
Yeah. What do you think it would cost
So,
to reproduce this today? In today's VFDs, today's steel, today's labor, bending, welding rod, consumables, all this stuff. What would it, if you had to transpose, what would it be?
boy, I think it'd be a $50,000 hammer.
Really, eh?
I absolutely do. Just at the cost of steel. I mean, there's a lot of steel in that hammer. Um, yeah, it scares me to think about it. I wouldn't want to build another one.
Yeah.
It was, I mean, not in today's what things cost today. Um, and I always knew I wanted a double, so I had the shrinking side, and that's never changed since day one. The shrinking
Mhm.
dies are always in there. Only thing I do is change the size of the shrinking die,
Right.
and the other side I change the dies quite a bit. And then I said, um, I want to do some things faster that I know you can do with a wheel. And
Mhm.
that's when I built the wheel, and I actually attached it to my hammer. So it's able to fold in and out. Made some massive hinges for it and welded it to the hammer.
Mhm.
Um,
Yeah, if you have the
and,
mass there, I mean, save some space, right?
oh, absolutely. It was just it was a no brainer. It had to be attached to the hammer.
Yeah.
And again, guys that do all their work with a hammer, they'll hate me for it, but there's no faster way to turn out a door skin than on a wheel. I could do it in half the time I can do it on a hammer. And
Because
so the combination of having a hammer with a wheel attached to it, I wish I had done that at the very beginning.
interesting. Why do you think that is? Why can you smash out a door skin quicker on a wheel than a hammer?
You can hammer out a door skin pretty fast.
Mhm.
And if you know what you're doing and where to hit it, and you've made more than one of them, you could do them pretty fast. Um, but not as fast as a wheel. That wheel, the wheel I built is completely different. It's another thing that's completely different than any other wheel out there. Um, when I set that thing to move metal, it moves metal. I mean, I
Yeah.
can put the tension on that pretty tight, and I can, you can put out a door skin in 6 minutes. You know what I mean? It's just it's amazing how fast that wheel will move metal.
Yeah.
It's crazy.
In terms of comparing your current hammer, as we wind this up, comparing your current hammer to some of the other stuff that's on the market, whether it's fabricated or whether it's, a replica Yoder, replica pettingell, something like this, comparing yours to maybe a tube structure, why does yours perform differently than maybe a tube structure does?
The mass of the hammer I believe, is critical.
Hmm.
Um, I use bigger dies, but I can hit hard and I can hit soft. So on my shrinking side, I don't go crazy fast. I go slow and hard with a
Mhm.
hard hit. And on the planishing side, I have a heavy die, but I also have the horsepower to just tickle the panel and make it work any way I want. So
Yeah.
the horsepower, the mass. When you get down to Connecticut, you can try it out and you'll see what I mean.
That's
You
right.
know, it's
I want to try
it,
the 13,000-pound hammer. We're going to
it
bring a
just
piece of 1/2 inch stainless and
yeah.
put it through there and it'll just clobber it.
Yeah, I'll tell you what. If I put that big set of shrinking dies in there, it'll almost suck you in the machine.
Oh my
Uh,
goodness. Yeah.
it's it, it's it's just, I believe I made it heavy because I was trying to do some overkill. I wanted it to be a solid hammer, and I wanted no vibration. And like I say, I've used some Yoders before, and I was like, they're fantastic, but I know I can do better. And the difference on the two of them is amazing. And and some of the newer hammers, uh, I don't know who's actually affording the new hammers because they're so expensive. I don't know who's buying them. Um, they don't hit anything like an old style spring leaf spring hammer. They don't hit anything like that. There's guys using them because that's what's available, and they turning out beautiful work with them.
Yeah.
But I don't think they're turning out as fast as they possibly could.
Do you think it's
Uh,
the vibration that's maybe the contributing factor to panel quality, or something different?
it hits different. It's not the dies. The dies again are made by a factory, not by a guy that's familiar with a shrinking die.
It's not made by
There's a
not made
mystery.
by Brian with a 20-foot belt sander.
There's there's a mystery around shrink dies. Everybody. Back
Yeah.
when everybody had their dies and they kept them in their old socks and they went to the factory and put them in the factory machines.
Hmm.
So everybody had their own die that they liked and they tuned over the years. And shrinking dies, I see them on the new massive machines, and they're taking a tuck that's tiny, and I don't believe they're getting the full benefit of a modern machine that can hit kind of hard, and I don't think they're taking advantage of that.
Yeah.
So it's slowing guys down, I believe, in making faster panels.
Brian, this has been fun. This
is all my opinion. You know, you could take it with a grain of salt, or for whatever it's worth.
Well, I mean, you know what? I think that's the biggest takeaway that I'm going to take from this episode is that like everybody has an opinion and a way that it works for them. And like you built a big, gorgeous hammer that model the Yoder, and somebody might say, "Oh, I can't fit that in my garage, and this is all I can, this is all I can fit, and this is all I'll use." And like that's what works for them, and this is what works for you. And I think at the end of the day, as long as something works for somebody, that's the point, right? We all learn from each other, and that's the point too. Is that's how the business evolves and grows, and the industry evolves and grows. And so if there's anything that I'm going to take from this episode today, it's the fact that, you know what, if you got the heart and you want it, like look at what you've built. That's fantastic. And it's totally achievable out there. So thank you so much for being on the show. Where can people find out more about you and your YouTube channel?
Just go to YouTube, search for Metal Shaper. I do a variety of things. I have a full restoration shop. I do sheet metal work. I rebuild engines. I do axles, transmissions, you name it. Anything that has to do with a vehicle happens in my shop. And there's a whole bunch of different stuff going on my YouTube channel. That's the best place to find me.
There you have it. Brian Hainer from Connecticut. Don't forget to like, share, follow, and subscribe. And we will see you on the next episode.